Hello guys, in this video we are going to look at an introduction to statistics. Last time we looked at the basics of data analysis, where we looked at the different data types in data and many more things. You can check out our previous video. So in this video we are going to look at we are going to get introduced to statistics in so we shall look at what statistics is. So this is a branch of mathematics that involves the collection, analysis, interpretation, presentation, and organization of data. To analyze your data, you have to first collect it, whether primary or secondary, then make some data transformations if necessary, make some data cleaning, and then analyze. Thereafter, you can do data present or report presentation of the findings after interpreting them. And so it is used to predict the future, determine the probability of specific events, and answer questions about surveys. For example, predicting the future, you could be interested in maybe predicting when the next war can happen, or if you want to determine the probability of specific events, maybe if you want to know the probability whether it will rain today or not, and maybe answer some survey questions. There are two major areas of statistics which include descriptive statistics. Descriptive statistics can be in form of the mean, median, mode, quartiles, uh, standard errors, ranges, variances, standard deviation, and more. It also has inferential statistics. Yeah, let's dive deep into the different areas of statistics. Descriptive statistics is a branch of statistics that involves the collection, organization, summarization, and presentation of data. And this aims to describe and summarize the main features of a data set. Um, Under descriptive statistics, we have measures of central tendency. Like, you want to know how your data is summarized. For example, you want to find out the mean of age in your data. You want to find out the median of something. You want to find out the percentiles, quartiles, standard deviation, and more. So the measures of central tendency, we have the mean. Because measure of central tendency is part of descriptive statistics. And in central tendencies, we look at the mean or average, and the mean is the sum of all values divided by the number of observations. When I say mean, I mean like if we have a data set that contains people's age, so the mean could be that value around which most of the edges rotate. Like if the mean is 20, it implies that most of the people's age is around 20 there, around the mean. So that's the mean. We have the median, and median in most cases is the middle value when data are ordered, and it is less sensitive to outliers than the mean. So the best when I say less sensitive to outliers than the mean, it implies that when your data has outliers, the median becomes the best measure of central tendency. We have the mode, and the mode is the most frequently occurring value or values in the data set. As you can see here, we have 3 and 9 as the most frequently occurring values in the data set. So let's look at the measures of dispersion. When I say dispersion, we are looking at how far away the data points are situated away from the mean. So to measure dispersion, you can use a set of scenarios. For example, range. Range is the difference between the maximum and the minimum values in the dataset. For example, if you have income of people in Uganda shillings, and maybe the highest income is 200 million, and the lowest is 200,000. So the difference between those two values would be the range, yeah, which is there. For example, the biggest value here is 28 minus 14, yeah. So the range would be 14 in this regard. So we have the variance. Um, Variance is the average of, yeah, the squared differences from the mean. Yeah, it measures the spread of data. Yeah, as you can see in this formula here, you can see as well described in the definition that it is the squared differences from the mean. So yeah, we have standard deviation, which is the square root of the variance, and it provides a more interpretable measure of data spread. Yeah, let's look at shape of the distribution as part of descriptive statistics. So we shall look at skewness, and skewness is a measure of the asymmetry of the data distribution. For example, data can be negatively skewed, which implies that the extreme values are on the left-hand side here, and it can be normal where we have no skewness. It can be positively skewed where the extreme values are positive, like they are very big. Yeah. We have kurtosis. Kurtosis is a measure of the tailedness of the data distribution. Yeah. So it measures the degree of pickedness or flatness in the variable distribution. Yeah, it can be Leucitic distribution where we have a low degree of pickedness. It can be mesochatic where we have a normal distribution, or it can be a leptochatic where we have a high degree of pickedness. Yeah. Another part of descriptive statistics can be percentiles and quartiles. And when I say percentiles, this indicates the relative standing of a particular value within the dataset. For example, if you want to know maybe the number of students, maybe, yeah, the number of students who scored below some given value, you can use percentiles. For example, in this here, we have like 75% of the students scored this or below. So yeah, we can have a 25th percentile, we can have like at 50% how many students scored below given maybe value, something like that. So we have quartiles, and quartiles divide the data into 4 equal parts. Yeah, with 3 quartiles. Yeah, we have the first quartile, the second, and the third. Yeah, which divide the data into 4 quarters. As you can see, the first quartile is at the 25th percentile. The second quartile or the third quartile is at the 75th, something like that. Another thing that falls into descriptive statistics, we have graphical representation of data. Yeah, and in graphical representation of data, we have a lot. I mean, we have histograms, we have bar charts, we have pie charts, and many more. Histograms, when I say a histogram, it will be a visual representation of the distribution of data of a data set. As you can see, we have the distribution shown there. We have a box and a whisker plots. Yeah, which are box plots. They provide a visual summary of the distribution and identifies potential outliers, yeah, in the data. We have frequency polygons, and a frequency polygon can be a line graph that displays the distribution of a data set. For example, this is a frequency polygon. Frequency polygons are always put on a histogram. Yeah, let's look at inferential statistics. Let's dive deep into that and know what it means. Yeah, and this is a branch of statistics that involves using sample data to make inferences or draw conclusions about a population. For example, you could be interested in the readership of maybe a certain book in the entire country, but you don't have capacity to interview or to collect data from other people in the country. But you may take samples from the population, and maybe those samples can help you make conclusions about the um, the book readers. Yeah. So inferential statistics, yeah, as I've explained, we have a population. From the population, you pick a sample, and then from the sample, you draw some conclusions regarding the population's features. Yeah. So instead of describing and summarizing the data like descriptive statistics, inferential statistics extends the findings from a sample to a larger population. Yeah. So it includes the following. Yeah. We have sampling techniques in inferential statistics. Like if you want to select a sample from a given population, you have techniques that you should maybe consider. There is random sampling where each member of the population has an equal chance of being selected. For example, maybe if you're conducting a census in the, maybe if you're conducting a survey in a specific school and you want to know the different perceptions of students, you may not necessarily target specific students, but you may randomly choose a student from the school, which is somehow described in the picture here, where people are chosen randomly or selected randomly. We have stratified sampling, and this kind of sampling divides the population into subgroups and then randomly sampling from each subgroup. For example, if I have a population that has middle income earners, low income earners, and high income earners, those can be my strata, the low, middle, and high. So from those strata, I can randomly select my sample. Yeah. Uh-huh. There is cluster sampling, and this divides the population into clusters and then randomly select entire clusters for sampling. For example, you have a population, and from that population, you select clusters, or you group the population into clusters, and then you go. This time round, it's not like stratified where you pick an individual from the group or strata, but in cluster sampling, you randomly select an entire cluster or an entire group that has people or anything, or all those units of observation. Yeah, there's estimation in inferential statistics, and estimation has like two, which include point estimation. Yeah, and this kind of estimation provides a single value as an estimate of a population parameter. For example, if you want to estimate a population mean, you can use a sample mean, something like that. There is interval estimation or confidence intervals, and these provide a range within which a true population parameter is likely to fall. Yeah, we have hypothesis testing in inferential statistics, and this basically helps us to make conclusions about the population. And hypothesis testing basically includes stating a null hypothesis, and a null hypothesis in most cases states that no effect or no difference or uh, is the default assumption. So the null hypothesis is like a form of hypothesis that is deemed true until proven wrong based on experimental data. For example, let me give you a scenario. Back in the days when those guys didn't know that the earth is round, uh, guys used it to think that the earth is flat, like this globe is flat. And until guys like Aristotle, Copernicus, and a lot more tried to prove that these guys are wrong. You get? So the null hypothesis was the Earth is flat because it was deemed true until it was proven wrong based on experimental data, maybe probing around the Earth. The alternative hypothesis is like the opposite of the null hypothesis, which states the presence of an effect. Like in the previous example I've given you, the alternative would be the Earth is round. Round, I mean, not flat. Um, there is a significance level in hypothesis testing, and this is simply a probability of rejecting the null hypothesis when it is true. Yeah. For example, if you've tested that the average age of students is not 20, so at 5% you would be rejecting that null hypothesis. There is type 1 error in hypothesis testing, which involves incorrectly rejecting a null hypothesis, yeah, when it is true. Yeah, for example, if the null hypothesis, for example, in this picture, the null hypothesis would be like this man here cannot be pregnant. You get? That's the null hypothesis because it is deemed true. But then after maybe thorough checks by the doctors, the doctor confirms that the man is pregnant. That would be like going to hell when you know. Yeah. So that type 1 error is like rejecting the null hypothesis when it is true. Like the true null hypothesis is the man is not pregnant. Yeah, there is type 2 error, which is failing to reject the false null hypothesis. For example, this lady looks to be so pregnant, but after thorough checks by the doctor, she confirms that the lady is not pregnant when she is pregnant. So that would be committing suicide. There is statistical tests in inferential statistics, and these statistical tests include parametric tests, which assume a specific characteristic about the population. For example, the assumptions that have to be made and satisfied if you want to use such tests. For example, a paired t-test, unpaired t-test, one-way ANOVA, Pearson coefficient. Then we have non-parametric tests, which do not make assumptions about the population parameter. For example, Mann-Whitney test, Kruskal-Wallis test, Spearman coefficient, and more. We have regression analysis in inferential statistics, and in regression we can have a simple linear regression which examines the relationship between two variables. For example, if you want to know if income is influenced by education level, so that would be a simple linear regression. Yeah, something like that, where we have a dependent variable and an independent variable. So we have multiple regression, and this analyzes the relationship between a dependent variable and multiple independent variables. For example, if you want to know the different determinants of income, someone can be having X1 as education level, family background, and more. There is analysis of variance. Yeah, we have one-way ANOVA or one-way analysis of variance, which includes or which means comparing means or averages of more than two groups. Yeah, you have maybe you're trying to find out the time it takes for the different drugs to cure maybe a certain disease. Yeah, for example, you want to find out the time it takes for the different painkillers to take away the pain. You have Panadol, you have painkiller 2, you have painkiller 3. So that would be the analysis of variance. It's a one-way ANOVA. There is a two-way ANOVA, which analyzes the influence of two categorical independent variables. For example, you want to know the time it takes for a man to reach maybe town when he has used route A or route B. Yeah, so it is used to determine the effect of two nominal predictor variables on a continuous outcome. In this regard, or in this scenario, the nominal predictors are route A and route B, and then the continuous outcome is the time it takes to reach town. We have chi-square tests, and this includes goodness of fit test, and this assesses whether an observed frequency or an observed frequency distribution differs from a theoretical distribution. Yeah, we also have a independence test, which assesses whether there's a significant association between two categorical variables. Yeah, maybe you want to know if gender is associated with education level. Yeah. So thank you so much for watching. In this video, we were trying to learn or to get introduced to statistics, which is a deep dive into data analysis.